Hello and welcome to this video from BlenderCookie.com. My name is Kent Trammell, and today I want to talk about accelerating your renders with a render farm. So first, what is that? A render farm is a cluster of networked computers that work together to render an animation sequence or even a single image significantly faster. Most production studios will fill huge rooms with server rack upon server rack full of thousands of rendering computers, or render nodes as you'll hear them called. But they're also useful as well as financially viable for smaller teams or even individuals. For example, in the Piero series, when each frame was taking about 10 minutes to render, all 1,037 frames equaled 10,370 minutes, or 173 hours, or 7.2 days on a single machine. And 10 minutes really isn't that bad for an HD 1080 cycles render. I was actually really happy with that performance. But with that many frames, time really starts to add up and it becomes impractical. Here's where a render farm comes in handy. Divide the total time by the number of farm computers we have. In my case, it's 4, and we can finish that same sequence in under 2 days. That's a big improvement, and it allows you as the artist to tackle bigger projects that require a lot of rendering time. And after using my farm for just 2 freelance projects, it already paid for itself. Now, you're probably thinking, multiple computers, but I spent enough money on just one. And you're right, financially a custom-built render farm isn't practical for everyone. But what's cool about rendering with Blender is that a farm doesn't have to be a custom-built cluster. It can be a collection of any kind of computer you find laying around. You can invite all your friends over with their laptops, or even a computer lab with networked stations. The only requirement is that all the machines are functional with the basic specifications for running Blender. They can be operating with Linux, Mac OS X, Windows, or even a mixture of each. In my case, I chose to build a custom farm inside of a filing cabinet. It works like a charm, and it's relatively cheap considering the computing power it delivers. 6 8-core CPUs with 16 gigabytes of RAM each is less than $3,000, which is pretty good in my opinion because that's less than some high-end single computer workstations. So for the rest of this video, I'll be focusing on my small personal farm, but don't forget that this information can also be applied to other computer setups like I mentioned before. Now let's talk about the build and the hardware. Item number 1, the Helmer filing cabinet from IKEA serves as the perfect enclosure for a small farm. It's actually kind of bizarre how well it houses all the components, and you can pick one of these up for $40 and even in a few different colors. I feel like the red and bright yellow would make your farm run at least 2% faster. Item number 2, an Ethernet hub. This is necessary for connecting our nodes to the network. I don't see a reason to get a fancy one. This inexpensive hub from TrendNet has worked great for me. But remember, we need at least 7 plugs, 6 nodes, and 1 for connecting to a router. Item 3, a power strip. Since the Helmer cabinet is mobile with wheels on the bottom, it's best to have a dedicated power strip for easy plug-and-go mobility. I think I bought mine at Target for like $20, but this one from CyberPower is an example of a slightly nicer one. Again, keep in mind the outlet count needs to accommodate all your nodes as well as the Ethernet hub. With this build, at least 7. Now, those 3 items are one-time purchases, but we need 6 of each of the following computer components. Item 4, the CPU. There's room for debate here, but I tend to think that the quantity of cores is a little more important than the speed when it comes to farm rendering. So I went with an 8-core 3.6 GHz Zambezi processor from AMD. Item 5, the RAM. The general rule of thumb when it comes to rendering is the more the merrier. In this Corsair 16 GB 2-stick combination fits my budget best. Number 6, the motherboard. I considered 3 major things when looking for a motherboard: dimensions, CPU socket, and graphics. It needs to fit on the floor of the drawer while still leaving enough room for the power supply and other components. Also, the board's CPU socket needs to match the desired CPU. And finally, we can save a lot of cash by not purchasing 6 graphics cards. Fortunately, there are certain motherboards that come with a basic graphics solution built directly into the board. This does of course mean that our farm will not be GPU renderable with cycles, only CPU. This smaller ASRock board fits like a glove, matches the Zambezi AM3 Plus socket, and has an integrated graphics chip. Item 7 is storage. A cheap 2.5-inch notebook hard drive is needed simply to boot and store the operating system. And in my experience, I haven't used these drives for storing other data because when rendering, my image files are immediately transferred to the output directory on my master machine. So it doesn't need to be high capacity. Item number 8, the power supply. This is a standard piece of computer hardware. Originally, I bought the cheapest one I could find, though after a few months they started overheating and dying on me. This Antec Earthwatts green power supply is still inexpensive, but has held up much better. And since each rendering node is lean, meaning there's no disk drive or graphics card to supply with power, I went with a wattage on the lower end of the spectrum, but be sure to check that it can support whatever components you choose. Number 9, a cooling fan. Another standard piece of computer hardware needed to pull cool air through the front ventilation while pushing hot air out the back. The dimensions here are important. The 80mm size fit perfectly for me. Item number 10, power buttons. We'll want to be able to turn our nodes on and off, of course. Number 11, LEDs. This is optional. I chose to add an LED to each node to tell me when the hard drive was in use. This isn't strictly necessary, but I think it looks cool and high-tech. Item 12, Ethernet cables. We need 6 standard Cat6 cables to connect each node to the hub. I recommend the 3 feet length. And item 13, PC screw and accessory kit. At electronics stores, you can find a convenient package of assorted screws, brass mounts, and washers that are likely to be needed when building a computer. During my build, I found myself needing several of these for random things. And that is all that we need. Again, all this hardware is less than $3,000. But admittedly, I'm not a big hardware guru. I've just done enough research to have an adequate knowledge. But I know that many of you watching this are hardware gurus, and you should be happy to know that these components are really only limited by your budget. If you prefer other hardware to what I'm using, then by all means, go with that, as long as you know what you're doing. I do know that if you want to build Mac-compatible render nodes, or Hackintoshes, as people call them, you need to find very specific hardware. Linux and Windows are much more flexible operating systems. And of course, being open source, Linux is best for my budget. But before we get to the software, I want to go over the building process. This is what the completed farm looks like. You'll notice that currently I only have 4 active render nodes. Eventually I'll get to the full 6, but I've been adding them gradually to soften the financial blow. If you choose the Helmer cabinet, you'll have to put it together yourself, so be sure to follow those instructions, except for leaving the back panel off so air can circulate through the nodes. Then you'll have to do some modification to the drawer pieces. 2 big holes in the back for the power supply and fan, 1 large rectangular hole in the side for access to video output, USBs, and Ethernet, 1 hole in the label slot on the front for ventilation, holes in the front for the power button and the LED if you want it, as well as holes in the floor for securing the motherboard. Since I had to drill and cut these same holes in each of my 6 drawers, I made a simple template so it was easy to copy the hole guides for each piece. And all these modifications can be done with a Dremel, a screwdriver, and an electric drill. You don't need a workshop full of expensive power tools. I built mine on the balcony of my apartment. But if you have access to a workshop with expensive power tools, you might as well take advantage. This is a close-up of the front holes for ventilation, power, and LED. The mesh covering the ventilation hole is from excess screen material I had laying around. The 2 holes in the back are cut out with a Dremel using a disc cutter bit. I recommend that you modify all 6 drawers at the same time, assembly line style, and be prepared to go through several cutter bits as they wear down somewhat quickly when cutting metal. Now for the components, first I like to lock in the CPU to its socket and install the RAM sticks. Then I secure the motherboard to the floor of the drawer. There are many holes in the board for fastening, but I only used 4, 1 for each corner area. I made a template from the motherboard to drill the same holes in all 6 drawer floors. Then I screwed in a brass mount to each hole in the floor before screwing the board into the mounts. Then we can go ahead and plug in the leads from the power button and LED to the appropriate pins on the motherboard. They should be labeled clearly enough on the board itself. Next is installing the power supply. Slide it into position, lock it with screws, then start plugging in a few of the leads to the motherboard. 1 for the CPU fan and the large 24-pin plug, and another to supply the CPU. Then secure the 80mm cooling fan to the back panel beside the power supply. This should be a very snug fit. Again, it's bizarre how well these components fit in these Helmer drawers. Then find the appropriate plug on the motherboard labeled for fan power and pop the smaller plug into the board. You'll then need to plug the bigger one into the matching lead from the power supply. Now for the hard drive, find a SATA plug on the motherboard and connect it to the SATA plug on the hard drive. Then grab a SATA power lead from the supply and plug it into the hard drive as well. There should be a convenient space behind the fan to tuck the drive away. And at this point, the render node is complete. We're ready to slide it into the cabinet. But notice how, once again, there's a convenient amount of space on the inner side of the cabinet housing for running Ethernet cables through. Plug one into the node as you slide it in. Then plug each node cable into the Ethernet hub and connect the hub to your router. Now repeat that process 5 more times and you will be ready for the software side of things. First is to install the operating system of choice, which you will need to plug in a monitor, USB disk drive, or thumbstick with the OS install data, keyboard, and mouse for each install on each node. I mentioned earlier that I chose Linux, specifically Fedora 17 LXDE. I found this one to be a very streamlined distro compared to Ubuntu, for example. But again, the operating system is completely up to your personal preference. I'm going to do my best to keep this platform agnostic because at this point the task at hand is general networking. So it doesn't matter if you've built custom render nodes or you're simply connecting arbitrary machines. The setup for network rendering in Blender is the same. But before we actually start rendering, let's think about efficiency, because it would be best if we could control all of our rendering computers from our main machine. Because otherwise, when I need to open Blender and troubleshoot a render scene, for example, I would have to plug up a monitor, keyboard, and mouse every time, which can be very slow and annoying. So I want to show you how to set up remote desktop control with VNC. VNC stands for Virtual Network Computing, and I think it's the easiest way to control one computer from another. So first, let's begin with the easiest platform setup and finish with the most involved. Mac OS X comes with a convenient VNC client already built in, and we can access these settings in the System Preferences and in the Sharing menu. Here over on the side we can see Screen Sharing, so we want to turn that on for VNC access. And whenever we're trying to target another computer through VNC, it's distinguishable with its IP address. Here in this case, this is my local IP address, 192.168.1.2. So for a VNC viewer on any other platform, we would type in this IP address to connect to this computer. And in computer settings, we have the option here to set up a VNC password. So we can turn that on and type one out. This way, when another computer requests access to this machine, it has to type in this password to verify itself. And I'll click OK. Then we have to verify this as the administrator. There we go. And that's it for VNC setup on a Mac. Let's test this by clicking the Go menu in our Finder, connect a server, or Command K to bring up this dialog. And we'll type VNC : / and the IP address of the computer that we're targeting. And this specific address is for a MacBook Pro that I have in the other room with the same VNC settings. So I'll click Connect, and I get this dialog, which I think is actually due to the Mac-to-Mac communication, where it requires a registered username and password. So I'll type that in. And there we go. That's the desktop of my other computer, and we can control it as if I was sitting down right in front of it, which is pretty cool. Now for Windows, it does come with some sort of remote desktop software right here called Remote Desktop Connection, but I've not had success with it, so I don't recommend it. Instead, I recommend Tight VNC. So if we open up Internet Explorer and go to tightvnc.com, this is a free VNC software for anyone to use, and I think it works really well. So over here we'll go to Download Now, Scroll down a little bit and choose the installer for Windows 64 or 32, whichever one you're running. I have already downloaded it, and if we click on the installer, we'll click Run, and because I'm already running VNC, it's only going to ask me for modifications. But when you are installing, I recommend that you leave all the default settings as is, and once that's finished, you'll have access to the settings, which can be found down here. This little V icon, if we click on that, where we have several different settings over here. I leave them all the same except for the passwords. Now there's two passwords here, unlike in Mac OS X, where one is the password for computers requesting access, and then the other one is a password to protect these settings here, where in order to even access this dialog and change my VNC settings, I have to type in that password. So I believe the primary password is for other computers requesting access, and the view-only password is for accessing the settings. So when using VNC, I recommend that you use a password just to protect your machine. So once that's set up, I'm ready to test the connection. And if we go back to that little VNC icon, if we hover over it, we can see our IP address that we would use to target this machine. Let's remember that and jump back over to my Mac. And the same way I did before, in the Finder, I'll hit Command K and choose 13 this time. Hit Connect. And now we have access to our Windows desktop. I'm going to press this little button here, which should shrink the window, or at least allow me to do that. So yeah, let's scroll that up. And we can also change the resolution, which should speed up our connection. So right-click in the desktop screen resolution, and let's change it to 800 by 600. Apply that. Keep those settings. And it looks like I've sort of messed up the resolution. So let's refresh this by closing the window and connecting to it again. Yeah, there we go. Now it's the full resolution, 800 by 600, which should run much smoother. And now I have complete access to my Windows machine. But there is one more thing that I want to change, and that has to do with the IP address, because as it is now, if I left the Windows machine sitting there to where it goes to sleep, when I wake it up, the VNC viewer will tweak out because it's looking for 192.168.1.13. But my Windows machine might change the IP address because by default it's dynamically setting the IP address according to the router. And what's annoying about that is if I want to VNC into this machine now, I have to figure out what its IP address is. And that can either be a guessing game, or I have to go to the computer, plug in a monitor, and see for myself what it is. So we can solve this by making the IP address static instead of dynamic. So I'll right-click on my little network icon down here, open Network and Sharing Center, and in Connections, I'll click on the local area connection, and then choose Properties down here. And for the Internet Protocol version 4, that's where I can set the static IP. And if I click that, choose Properties, by default it's set to obtain an IP address automatically. But for VNC purposes, I want to keep the IP address the same so that I always know where to find that machine through VNC. So the IP address that I want to use is 192.168.1.13. Hit Tab, which should automatically fill in the subnet mask. And then the default gateway, I believe, is the router, which should always be 192.168.1.1, I believe. Well, I shouldn't say always for every computer. You'll need to figure out this information on your own network. But for my router, I know that it's 1. Hit OK. We'll close out those settings. This way, I will always be able to access this machine at this address ending in 13. And while I'm still using the Windows machine, let's test that the VNC works to my MacBook Pro that's in the other room. we'll click on our Start button down here. I'll type in Viewer because when TightVNC installs, it also installs the TightVNC Viewer, which is how we connect to other machines. So the number for my MacBook Pro is 198. Let's hit Connect. And we get an error. Let's see, there must be something wrong with the address that I typed in. Let's try the Wi-Fi address for the MacBook Pro. And yeah, that seems to work. So we'll type in the password that I set up, hit OK. And there we go. We're connected now to our MacBook Pro. If I just log in, we have complete access to our MacBook Pro from the Windows machine, which is actually being controlled from my Mac Pro. So it's kind of like Inception. We're like 3 levels deep inside VNC. But yeah, that's how it works for Windows. With Linux, it's a bit more of a manual process to get VNC to run the way it does on OS X and Windows, where the goal for usability would allow me to power on the render node, sit down at my main machine, connect to the assigned IP address, and it's ready to go. That way there's no user input into my render nodes, only the main machine. So first things first is to enable auto login. Like the other operating systems, whenever Fedora LXDE boots up, it goes to a login screen. The only difference here is that the VNC application is not enabled until after we log in. So we need to make it auto login so that VNC can start up. And we'll do that in the terminal. And we'll type sudo nano /etc/lxdm/lxdm.conf. Now I will do my best to explain what these commands are, but just so you know, I'm not a Linux power user, though I think I can explain it well enough for most people. So sudo is like the super user command, meaning I'll need to type in my password. I am the administrator and I'm running this command. Nano is the built-in text editing application that's very basic and very bare bones, still all done through the terminal. And then it's the directory to this configuration file. So with that typed, I'll hit enter and it'll ask for my password. And even though I am typing, nothing's showing up. That's just how terminal protects your password being typed. I'll hit enter and the password is correct because it opened up Nano. And we have several different lines here. A few of them are commented, and at the very top we have uncomment and set auto login username to enable auto login. So if this is a fresh install, this file should read like this with a pound symbol in front of this auto login equals, and after the equals will be dgod. This is what the default will look like. So you'll change this to be whatever your username is and remove the pound symbol at the beginning. And then we'll hit Control X to exit. It's asking if I want to save the modified buffer. I will hit N for no. I do not want to save that. But now when I reboot Linux, it should auto log in straight to the desktop. Now the next step is to install a VNC client. The one that I've had most success with is X11 VNC. And to install that, again, we'll type sudo yum install X11 VNC, which is the same super user command saying that I'm an administrator performing these actions. Yum, which is some sort of application repository protocol, I believe. And then the command is install and the name of the application that I want to install. So I'll click enter. And since I've already typed in my password just a few moments ago, it went ahead and looked for the package. But I've already got it installed as the latest version, so there's nothing else to install. But if you run that command and you don't have it installed, it will simply list the application as well as any dependencies that need to be installed. You'll say yes or no, and it will either install automatically, or if you click no, it will cancel. Now to run X11 VNC, we will simply type X11 VNC, and the application opens, or it's running inside the terminal. And if we scroll up, let's see here, we have all kinds of instructions and information about the application. The first one, which is storing the VNC password that other computers will need to type when requesting access to this machine. And there's a couple different commands that are different versions of the same thing. We will just use this one right here, x11vnc store password. Let's copy it. And then at the bottom, let's see if we can paste that. Or actually, let's escape. Hold on, how about Control C? Yeah, I think up at the top, let's see, the very first thing it says is by default, we're running the VNC server without a password. So it throws up a bunch of warnings. And if you didn't mean to do this, press Control C, I guess, which quits the VNC client. So anyway, that's why I pressed that. And let's see if we can paste our create password command. There we go. Hit enter, and it will ask for the VNC password. We'll type one out. Hit enter. It'll ask for it again. Hit enter. And it will ask if we want to write this password to our home directory, .vnc, a hidden folder, and password is the name of the actual file. I will hit no since I've already done this. And now we're ready to access this machine from other computers. But again, the ideal functionality for this is to start up automatically whenever I turn the computer on. So to make x11vnc run once the computer is logged into, we need to edit another file. So let's cd or change directory and then type our directory. That little tilde represents our home directory, then /.config /lx session /lxde, hit enter, and now we're inside that lxde directory, sudo nano auto start. This is where we define our programs to auto run. Let's type in my password again. And in this file, we only have one command, one application that I want to auto run, and it's ampersand x11vnc, the name of the application, -forever, which is a command for x11vnc to run as long as the computer's on, -usepw or use password, the one that I created just a few moments ago, and then -geometry 800 by 600. This is scaling our screen resolution down to make the control connection a little bit faster. The actual resolution of my Linux desktop it's like 1076 or something like that, but this geometry tag will allow you to scale it up or down. So with that line added, we can hit Control X to exit. Since I didn't make any changes, it just quit, but for you, it will ask you again to save, so be sure to do that. And that's actually it for the terminal. There's only a couple more things to change to make VNC work the way that we want. And the next one has to do with the firewall. So we'll go to Administration, Firewall, where we need to type in our password to change any of these settings to prove that we are an administrator. And over here on the left side of our window, we have a few categories. In Trusted Services, if we scroll down, we see all kinds of things like mail, SMTP, FTP, POP, but we actually don't see VNC. So in order for the firewall to allow VNC connections, I need to add a port inside of other ports, specifically port 5900. Now I believe this is the default VNC port because it's the same port on Windows, but I got that number inside all that information when I first ran x11vnc. Right here you can see it says auto probing selected port 5901, and down here it says the VNC desktop is port 5901, and then I confirmed that with a simple Google search. So back to the firewall. Whenever you add another port, it gives you this enormous list, and if we scroll down to find that specific port, let's see what it tells us. 5900. It says it's RFB is the name of the service. So you can either select those, or I just went ahead and defined my own 5900. I added one for the TCP protocol and then another one for UDP. just to be absolutely sure that that port is allowed. I'll hit cancel and you can see those two are added right there. If you don't make an allowance for these ports inside the firewall, you'll never get a VNC connection to work. And with that set, there's only one more setting, and it's the same one I did for Windows where I set a static IP address, but we can set that up over here in Preferences, Network Connections. And it is a wired system because there is no wireless card. It's only hooked up through an Ethernet cable. So if we click on that one and choose Edit, let's go over to the IPv4 settings just like we did in Windows. And we have the option to add addresses and delete addresses. So I added this custom one in, 192.168.1.11. Same information from Windows as far as the net mask and the gateway. And then the DNS server is also the router location, I believe. At least that's what worked for me. And then just save that out. And this machine will always be reachable at 192.168.1.11. And now let's test the connection from my Mac machine. Hit Command K from the Finder. And here you can actually see how I've set up the farm. I have 4 machines right now. And in order to make them not compete with the lower numbers, for example, farm number 1 couldn't be 192.168.1.1 because that's the router. So I just made it 11, 12, 13, and 14. And since they all have static IPs, I know that they can all be reached at this same address every time. So with .11 selected, let's connect. And there we go. It pops up and is now completely controllable by my main machine. All right, so now we have a collection of networked computers that are all controlled by a singular master machine. This means we have a farm and we are finally ready to render something. So I'll open up Blender and I have a test scene that I've created specifically for this that should render pretty fast. And it's a very simple scene, just a monkey head sitting on a big plane, one light, and an HDR environment map. We are rendering in cycles. And if I scrub through the timeline, the light twists around, as well as our monkey head coming to rest in its original position. Just something to show animation. And if we take a look at our render settings, they are pretty basic. Let's see, bounces, max of 2, minimum of 0, so it'll render quickly. I'll go ahead and turn on no caustics, and the sampling, render of 400. This is intended to render very quickly. I'll do an initial test of only 5 frames, just to make sure it's working on all my render nodes. And the output, let's select a directory here. So in my project directory, I just have a folder called REN for render. I'll accept that, and a simple JPEG will be fine for the render output. And let's see, I'll go ahead and do a quick render just to show you what this is supposed to look like. And here we go, nothing special, very, very simple. I will go ahead and save this file. And now I need to enable the add-on that allows us to render over a network. So on my Mac, I'll hit Command, comma to bring up my user preferences. Go to add-ons. Let's type network. We can see network render appears here. Let's enable that guy. And the network renderer shows up as an alternate render engine. So let's pick that. And we get all new render settings. So we have 3 options for our different machines that will be involved in this network rendering. We have the client, who doesn't actually render anything. They simply kick off the render job. And then we have the master, who also does not participate in the actual rendering, but kind of delegates the job out to our slaves. And the slaves are the machines that are actually doing the render computing. And this original instance of Blender, I'm going to make it the client. I'll scale the window down a little bit, turn on client, and now we need a computer to be the master, which can actually be this same computer. So I'm going to open my terminal, open a new window, and I have a recent command to launch Blender. So I'll launch another Blender. Let's scale that guy down as well. Likewise, I need to turn on the network render add-on. and we will make this the master. And let's make these settings a little bit bigger. And if I click Start Service, we get an error immediately. And this just has to do with Blender. Anytime I'm rendering something, I have to have a camera in the scene. So I'll hit Shift A, add a camera, doesn't matter where it is. And I don't need to open this test file either. It can just be a blank scene in Blender as long as there's a camera. Now if I hit Start Service, we get the render window. And if I jump back over to the terminal from which I launched this instance of Blender, we get updating that says broadcasting address. And this will repeat and repeat because it's looking for slaves to send the render information to. And at this point, I'm ready to go to my other farm nodes and open Blender and enable them as slaves. So I'll hit Command K to connect to the server from my Mac. And we'll start with number 13, which is my Windows machine. I'll open up Blender. Same deal, go to User Preferences, load the add-on. And we'll enable slave mode. So this big button right here, Start Service, if I click that, ideally, automatically it connected to the master instance of Blender because now it says network render connected to master waiting for jobs. So that guy is set up. Now let's open up one of my Linux machines. And I will navigate to my downloads folder where I have Blender downloaded and ready to open. And the same way, I will enable this as a slave. But you notice that I got an error here that says no master server on the network. Now, I don't really know what causes this, but by default, this address field right here, see if I can make this a little bigger. This address here is asking for an IP of the master render server. So by default, it says default, and that means it tries to figure out the master on its own, where the Windows machine actually did figure it out on its own. But if you get that error, try typing in the IP address. I know it's 192.168.1.2, which is the computer that is running the master. Hit enter, start service again, and there we go. It says network render connected to master and waiting for jobs. Very nice. Now let's just open my MacBook Pro, Command K, and I believe it's 198 is the right IP address. And no, it must not be. When it takes this long, it means it's searching for an IP address that's not available. So let's see, I must not have set this up as a static IP. And you can see firsthand why this is annoying, so I'm going to pause the video and go figure out what that IP is. And I see now that it's actually 201. Type in my credentials. And you'll notice that you get a checkbox here to remember this password in my keychain. Now this will prevent me from having to keep typing in these credentials. However, when the IP address changes dynamically, the password that's been remembered in the keychain doesn't associate with that address anymore. So I'll hit connect, and then I'm going to set up a static IP for my MacBook Pro real quick just to show you how that's done. So open up System Preferences, go to Network, and under Location, it should be default set to Automatic. So I'll click on that, choose Edit Locations, and I'll click the plus button, and I'm going to name this Static. Hit Done, and it creates a new set of network settings. And since it's my laptop, I'll choose Wi-Fi, and then choose the Advanced Settings. And under, let's see, TCP/IP for configure IPv4, using DHCP means that it's automatically choosing an IP address. So I'll switch this to manually, and then it gives me the option to type in what address I want. Now be careful here because you don't want to set this to another device that's already using the IP. So I know that this number 20 in particular is not being used. The subnet mask is 255.255.255.0 and the router 192 let's see, .168.1.1, and that's all good. The DNS, I'll go ahead and add one of these and also make it the router. Hit OK, and now choose Apply to set these settings. And you'll notice that the window freezes and it says reconnecting because it's looking for my MacBook Pro at the old address, .201. So I can close that window and connect to 20 instead. And I'll have to enter my credentials one more time, but when I check remember this password in the keychain, it will remember these credentials and I won't have to type them anymore. And also will always be able to find the MacBook Pro at that same address. There we go. Now that's all set up. I just need to open up Blender and set it up as a slave just like the others. And there we go. This one connected to the master automatically. And now all three of these nodes on different platforms are ready to render this sequence. So going back to my client over here, I'll hit the refresh button just to detect all of my new slave nodes. And we have a drop down called Slaves Status. Let's hit that refresh button and we should see all of our slaves pop up with the name of the device, the address, some stats about the operating system, and when the slave was last seen. So below the refresh button we have a minus button, and if I click that, it sets the selected slave to be blacklisted, and it puts it down here under the slaves blacklist drop down. And basically this is a way to exclude any of my nodes from rendering. So for example, if one of your nodes keeps giving you problems, you can overlook that node. Alright, I think I can make these a little bit bigger, hopefully a little more readable for you. Okay, so down below we have the jobs drop down, which we haven't actually kicked off a job, so that's blank. And then below that is the output. I believe this is copied from the settings that we set when we had cycles as our engine of choice instead of network render. So it should be plugged up to the same directory that we already chose, and it is. Let's see, it should be JPEG. Yeah, that's all the same. And then back up towards the top, let's see, we have a few buttons. Kick off an animation on the network, start rendering a job on the network, bake on the network. So if we want to bake physics or a cloth simulation, for example, we can spread that to the network as well, not only on our master machine. And then send current frame job. I suppose this is useful if I just want to see 4 rendered again. We can use that. And then we have a couple buttons, get image and get animation. And these come from the way that the network render add-on functions. And what it does is when I click send job to the farm, it will take the blend file and any external files that are associated with the blend file, for example, texture files, and it will send those across the network to each slave and specifically their temp file. So if we go pick our Linux node over here, by default there's a path for temporary files, and this is where the incoming blend file comes from, also any external files, as well as the actual frames that are rendered on this machine go to the temp directory. And then going back to the client, when the render has finished, I can choose get image or get animation that will pull the render frames from our slave nodes and save them to the directory that we defined in our output. So that's what those buttons do. And then below that, we have a type here for Blender, Process, or VCS. I never actually use the top two. I just render Blender scenes. And then we can add a name here. I'll call it farmtest.000. And we have a couple fields for category and tags. These fields are most useful if you're rendering a big job and you have a lot of render jobs going on at one time. You can better filter out the jobs if you've set categories and tags. And below that we have cycles. This is the render engine of choice. This needs to match what you used in your actual file when you set it up. So I want to make sure this is set to cycles. And then priority. Again, this is mainly useful for a big production where you have a lot of render jobs going at one time. You can set how important the job is, where more important jobs are pushed to the front of the line, so to speak, so they can finish sooner. And to the right, we have chunks. This is how many frames each slave node will render before checking back with the master. So it's set to 2. This means each slave will receive the job, render 2 frames, and then check back with the monitor to pick up another 2. Whereas if we set this to 5, it will render 5 frames in a row and then go back to the master to pick up some more. So for this test, we only have 3 render nodes and we're only going to 5 frames. So I'm going to leave the chunks at 2 to make sure that each node has a chance to render some frames. So let's see here. Oh, I want to remove my Windows node from the blacklist. I want it to participate in this render job, which we are now ready to kick off. So I will click Animation on Network. All right, so it looks like it started. Let's check the master. So it looks like it's receiving the log file and also sending the information off to our slave nodes. Let's take a look at the terminal, see what it's saying. Okay, it looks like it's still broadcasting. Now let's check our nodes. Okay, there we go. So it says frame 1, render file farm test A for job number 8. And then let's look at the other ones. And yeah, they all say the same thing, job number 8. All right, success. Okay, so we've received our first render result, and actually to monitor the render job and the progress and things like that, we have a great little utility that if we click Open Master Monitor inside our web browser, we get a new page. And let's just reproportion this so you can see it a little better. That shows us all of our jobs, all the way from 1 to number 8. So I tested this out 7 times before I felt ready to show this. And we also have information about our slaves, as well as some configuration settings down here. I never really touched those. Let's see, so this is, I guess, the old interface, where I typically use the new interface, which is a little bit fancier, I guess. But it's all the same information. And if we click on job number 8, we can see general information such as the resolution, number of frames, job name, render time, all that stuff. Files, which is the job path or the path to the original .blend file, as well as any other files that we have associated. So in this example, the HDRI that I have as the environment map is recorded here. And then we can look at frames. We can see that frame 1 was finished in 48 seconds on my Linux machine. Frame 1 and 2 were finished in 48 seconds. Frames 3 and 4 took 82 seconds, so about twice as much time, which is interesting since they're built out of the same hardware. The Windows node rendered half the speed. And then my old MacBook Pro from 2008 is bringing up the tail end at 191 seconds. We can also see thumbnails of our frames, which can be pretty slow since it's across the network. But anyway, that's pretty cool. We can get an idea of what was rendered. And then more slave information, but since the job is finished, there are no assigned slaves. And that's the specific job information that we have. On the main page, we have a couple buttons over here. P stands for pause the job. R is to restart the frame, or reset the frame, I mean. And then the X is to remove the job. So I can go ahead and remove these previous jobs where it asks, do I want to delete the files on the master? This is referring to any temporary files that are temporarily being stored on the master. I'm okay to get rid of those. And then per job, we have information like the ID number, category, tags. This is where I typed in category and tags, which didn't seem to take the info that I plugged in. Oh well. You can also, from this user interface, you can change how many chunks, also the priority. And then we have usage, which I believe is the usage of the farm, how many machines are being used for this job. Wait time, which I believe is the amount of time since our slave nodes last contacted the master. I believe that's what that is, but I may be wrong. Status, this job is finished since it's completed all 5 frames. Number of dispatched frames is 0 because it's finished. And if there are any errors that happen in the render, this button will light up and will allow you to reset the errored frames. And then a couple other settings, priority R and exception R. I'm not really sure what those do. I have never had to use those. Let's see, another button down here, cancel all the jobs if we want to just clear out the render farm. And yeah, that's about it for this user interface, but it's extremely helpful. Gives you a great overview of the render job, how it's doing, the progress. So I love that this is included with the NetRender add-on. All right, so let's go check out our frames. First, let's see if they made it back to our original output directory, which they did. So let's take a look at them. Frame 1 looks good, 2 looks good. Ooh, 3 does not, 4 does not. 5 does look good. So whose fault is that? We can check in the master monitor user interface. Let's go to our frames tab for the job, and it looks like 3 and 4, the Windows node, did not source the HDRI environment map properly. And unfortunately, I believe this is a bug. I've seen a few other users point this problem out as well. So if I go to the Windows node, let's see, where is it at? Right here, and I want to go to the directory, the temporary directory that we defined right here. So let's select that, we'll copy it, and open up a Windows browser, paste that directory in there. And in one of these slave folders, I assume it's the most recent, there should be a job number 8 somewhere. Here we go. Job number 8, where we have frames 3 and 4, that's correct. But we have the HDRI file right here. Now, Network Render changed the name when it transferred the file to the slave, but it did the same thing on my other computers, my other slave nodes, which worked properly. But with the Windows machine specifically, it doesn't refresh the path to the external files appropriately. But luckily, we can fix this pretty easily. If I go back to my client instance of Blender, this one right here, all I need to do is simply pack my external files. So under File, let's find External Data, Pack into Blend File. And we can see over here, if we pull this down, packed one file successfully, and that's the HDRI environment map. That's the only external file I have associated with this .blend. So now, let's see, I can save this file after I've packed it, and then refresh the client. Everything should be connected to the master still, and oh, that's kind of weird. We had a few duplicate slave entries, but refreshing that fixed it. And let's go ahead and submit this job. Oh, I see, my category and tags field are blank. I wonder how that happened. Let's see, let's make it testing and monkey as the tag. Now let's save the file and click animation on network again. I'm sorry about that, I had a crash. But maybe you noticed already that I've been using various versions of Blender across the farm. My main machine is 2.67, my Windows node is 2.68, and my Linux node is like 2.66 or something kind of old. And as you saw previously, it rendered across the network no problem. But when I tried again, it kept hanging on this error saying version check. So I went ahead and installed 2.68a on all the machines, including the 2 remaining Linux nodes. and set them up as slaves, which we can see here in my slave status list. We have the MacBook Pro, Linux node number 4, my Windows node, and Linux node 2 and number 1. For this last render job, I want to give you the full effect. And let's see, we'll change it back to cycles, where the end frame is now number 48 to complete the twist of the monkey head. And it is that same packed file. If I hit save, it says no new files have been packed. But before I kick this job off, first let's go back to Network Render. And then I'll go back to my terminal here on my main machine, create a new window, and launch another instance of Blender. And I will also set this one up as a slave node so that it can also participate in the render computation. So set it as slave, start service, and yeah, it's connected to the master as well. So if I go back to the client and hit refresh on our slave nodes, we should now have the Mac Pro as part of the slave network. And at this point, I will hit animation on network. And if we jump over to our master monitor, let's refresh it. And we have a new job. And we can see over here that out of 48 frames, 12 have been dispatched. So if we click on that job and look at our frames, we can see that all of our render nodes are working on this same job. And you might be able to hear the fans as they have kicked in. So I will give this a few minutes and pick it up again after the render has finished. There we go. The render has finished all 48 frames. Let's click on the job. And let's see, the render time took 10 minutes and 50 seconds, about 11 minutes. But below that, we have the cumulative render time, which is right at an hour. So yeah, with the farm, it takes about a sixth of the time. Now, if we take a look at the individual frames, we can get some feedback as to which nodes were rendering the same scene a little bit faster. And on average, all of my Linux nodes, number 2, number 1, and number 4, were between 50 and 70 seconds, which is about the same as my main machine, the Mac Pro. And the Windows node was still rendering slower, which again is very interesting because it's the exact same hardware as each of my Linux machines, but it's rendering sometimes 30 seconds slower. And still the MacBook Pro is way behind at 151 seconds. And now let's check if all my frames rendered correctly. I have the image sequence loaded up here in my DJV view. And let's play that. Yep, everything works fine. Packing the blend file has solved the texture sourcing issues. And yeah, our render farm works. Now, I realize that setting up a render farm is a fairly involved process, especially if you build custom render nodes, but hopefully you can see just how valuable it is once it's set up, whether it's a custom build like this one or a bunch of arbitrary computers. Speaking from personal experience, I cannot express how convenient it is when I have something I need to render, whether it's a model turntable or an actual animation. I can just go over, turn on my farm, and have the render finished in a fraction of the time that I was used to just on a singular machine. I'm actually kind of spoiled by it. But that's it. Thank you for watching.